Welcome to RGES Pre-Algebra. This is Lesson 29B. Today we will be discussing perimeter and circumference. As always, I would like to begin with a devotion. And this scripture out of Isaiah is a wonderful promise. It says, "You keep him in perfect peace, whose mind is stayed on you, because he trusts in you." Okay, there's three things I think we want to notice in this passage. The first one is that it is God who keeps us. You keep us. And that he's actually keeping us. It's not that we flit in and out of it and in and out of it. Now, there's some reality to that if we are not doing the condition it's talking about here, we can flit in and out of it, but that he keeps us in peace. We don't have to experience momentary peace and then long periods of frustration, confusion, anger, but we can be kept in peace. It can be ours to stay during the morning, during the afternoon, during the evening. It's perfect peace. It's not a partial peace. It's not a peace based in temporal things that will shift the moment we are not in that circumstance or not in that experience. It's a perfect, steady, reliable, ongoing, deep peace. But there is a condition. He's going to keep only certain people. This is the condition, whose mind is stayed on you. That's the condition. That's the qualification. We will be kept in peace as we plant our mind on him. It's stayed. It's continuously. We keep drawing back to it. I don't mean that I, from morning to night, sit in my chair and worship or read the scripture. I've got things to do, and so do you. We move into that his presence, and then we move on to, we do our work, but we're always, have the Lord right in the back of our minds. And if we start drifting away from that, we continually pull it back. Okay? Keep pulling your mind back to what? Remembering who he is, and what he has done. That's where our peace gets settled. We're putting our mind on him, not on who we are, not on what is done around us or to us, but who he is and what he has done. Very important. So I'm always remembering the goodness, the faithfulness, the wisdom, the power of my God. Because, why do I put my mind on him? Or in what state am I when my mind is stayed on him? It's a condition of trust. My heart has trust. I trust him. I believe these statements that he is good. Who is he? He's good. He's almighty. He's merciful. He's kind. You dwell on his character. I believe that he has been my hope in the past and that he will be my hope in the future. That he has shown up for me and delivered me in the past, and therefore he will deliver me in the future, right? So you keep your mind planted on him and you will have perfect peace. Let me read it one more time. You keep him in perfect peace, whose mind is stayed on you because he trusts in you. Now we're going to go on to our review of the last class lesson, which was 8:16. So if you have not brought that with you, go ahead and put it on pause. Go get your work. Make sure it's completed. This is the assignment. And come back when you're ready to correct it with me. All right. Now our concepts that we discussed last time, we talked about naming triangles according to their angles, naming triangles according to the length of their sides, we've talked about what it means to be similar triangles or congruent triangles. We've talked about 3 congruent triangle theorems. And we also, let's see, it seemed like there was one other thing we discussed. Well, I guess we'll run into it if we do. All right, so let's go on with our answers. The first ones are just making sure you understand your definitions. How many degrees are in a right angle? 90 degrees. How many degrees are in the angles of a triangle when we sum them all? 180 degrees, very important idea. What is the symbol of congruence? The symbol of congruence is a squiggly line on top of an equal sign. Okay. How many vertexes? That would be corners, right? If this were an angle, there's the vertex, right? So this is the vertex, this is the vertex, this is the vertex. There are 3 vertexes in a triangle. What is an equiangular? Well, we have the word equa, meaning equal, angular, meaning angles. So equal angles. Each one of them, by the way, would have to be 60 degrees, because 180 degrees, which is the sum of the angles divided by 3, the number of angles in a triangle, gives me 60 degrees for each. Okay, so that's an equiangular triangle, number 5. Now, the answer they give in the book is a triangle with 3 congruent angles. Okay, so you could first word it that way, or you could say, it would be more properly to say that, or to say 3 angles of equal measure. Now, I don't usually get that particular at this level. We would look for that more at the high school geometry level. Is a triangle equiangular if the triangle is equilateral? Yes. Why do we know that? Okay, if the angle, okay, so we start off with an equiangular. If the angle is, what did we actually tell you? We told you if 2 angles are the same, so these have the same measurement, then the opposite sides are the same. Okay, so if the relationship, there's a 1-to-1 relationship between the length or the measurement of an angle and the length of the side. So if that is a measurement of x degrees, then this has a length of x degrees on this side. If this is a measurement of x degrees, then this has a length of x degrees. Okay. So if 2 angles are equal, by the way, we also know, let's see, what is my question number 6? If a triangle's equiangular, okay, if I know that this angle is equal to this angle, I also know that the third angle is equal. I'm giving you a little bit more information than the question is asking. And so that would also be x, and that would also be capital X for the measurement of the line. So if you have equiangular, all the measures are equal, then we know that all the sides are equal. So the answer, this is number 6. The answer is yes. Make sure you know that. All right. Now, the next thing we want to talk about is number 7. How many congruent sides are in a scaling triangle? That's just a definition. A scaling triangle has 0 congruent sides. Right? This would be an example of a scaling triangle. All the lengths of the 3 sides are different. What is the symbol for triangle? Well, just like that. And by the way, it's named by the sides. Let's say this is ABC. Then we would talk about it by saying triangle ABC, just like that. Okay, classify each triangle as acute, obtuse, or right. Well, let's review the idea. Acute means all 3 angles are less than 90 degrees. Obtuse means one angle is greater than 90 degrees, and right means one angle equals 90 degrees. So your answers will be number 9, right, 10, obtuse, next, acute, next, right, next, acute, next, acute, number 15, obtuse, number 16, right. Just an understanding of those definitions. Classify each triangle, as equilateral, isosceles, or scalene. Again, definitions. We've already talked about a scalene when we were talking about this one up above, but a equilateral triangle has all 3 sides equal. A isosceles triangle has 2 sides equal, and a scalene triangle has no sides equal. So, following those definitions, number 17, scalene, next, equilateral, next, isosceles, next, equilateral. Next group, determine if the pair of triangles are similar or congruent, and give the appropriate abbreviation to support your answer. Okay, so for this group, we have similar triangles, and that means they have the same shape, but not the same size. And what would cause that to occur? If 2 angles of one are equal or congruent to two how do I want to say this? Let's see. Let's do it this way. 2 angles of triangle A are congruent to 2 angles of triangle B. Now, we already know that if 2 angles are congruent, the third angle will also be congruent. So what governs the shape being the same in 2 triangles is the idea that the angles are equal, not the lengths of the sides, all right? But the technical explanation is this, and we don't talk about the third angle because we know that if 2 are equal, the third will be equal. So we call this AA. That's my reasoning. Angle, angle. That means the angle of one angle's equal to the same angle in another, and this angle is equal to another angle in the other. Okay, what do I mean by that? Let's look at it. Okay, let's say I have one triangle here, and the value of this is x, and the angle here is y. These are not equal to one another, but if I have a triangle over here, and this is also the same angle, x, and this is also the same angle y, even if it's flipped around, drawn upside down, it doesn't matter. If they share angle x and they share angle y, then these are similar based upon angle, angle. Okay. Now, congruent, there's 3 ways in which, first off, the definition of congruent triangles is they have both the same shape and the same size. So if you were to cut one triangle out and lay it on top of the other, they would have the exact same angles and sides. Okay. So there's 3 congruent triangle theorems that you need to know. Side, 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 if all 3 sides are equal. Angle, side, angle. That would be if this angle is equal, this side, this angle, this side, and this angle, okay, are all equal. Doesn't even have to be the same like that. Let me draw that a little bit different here. Let's say that this angle over here is obviously different from the first angle. Maybe it's like that. Okay, but if the angle, the side, and the angle over here are all equal in one, even if it's, then in the other one, if that angle and that side and that angle are all equal. Not only are they similar because they have two angles, but they will actually be congruent. All the other lengths will be the same. Okay, like I say, in a formal geometry class, you prove all of these ideas. You show why it must be so. But right now, they're just asking you to learn them. Side, 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 angle, or side, angle, side. Those three. Okay, that means what? This side, this angle, and this side. If you have that condition in one, and that same condition in another, then the whole triangles will be congruent. Side, angle, side. All right, so now having reviewed that, let's go ahead and give you the answers there. And we'll go to the next page for that. And I consider this part very important, so you make sure that all your answers here in this section 8.16 are correct. Or if they're not correct, you make sure you understand how to change them so they would be correct. Number 21, these two triangles are congruent, same size, same shape, and the reason, because of the labeled measurements, is angle, side, angle. So you want to say congruent, ASA. Number 22, one smaller than the other, but they are similar. They're similar because two angles are similar. In fact, all three are, because if two would be, three would be. And so your reasoning is AA. So number 22, you should say similar, AA. Number 23, you should say congruent, the reason, SSS, side, side, side. Number 24, congruent, the reason, SAS, meaning side, angle, side. Now let's go ahead and look at your sharpening skills, reviewing your definition of geometric figures. Number 1, a square, they're asking how many line segments. Number 1, 4, next 3, next 8, next 4. Number 5, 3, next 5, next 4, next 6. And you should be able to draw any one of those figures if I asked you to. Write the definition of each. Congruent triangles, we've covered this, but congruent triangles are triangles with the same size and same shape. Number 10, equiangular triangles, an equiangular triangle has 3 equal angles. All the angles are equal. Number 11, supplementary angles are 2 angles that sum, their measurements sum to 180 degrees. Scaling triangle is a triangle that all 3 sides have different measurements. Array is a line with one line segment, okay, and then going infinitely in the other direction. That's array. One line segment and drawn out. An acute angle is less than 90 degrees. A polygon is any simple closed curve or simple closed shape, simple closed figure, we could say that, or simple closed curve, okay, that is composed of line segments. So this is a polygon. That is not, right? Because it's not line segments. That is not. Why? Because it's not a simple, right? It intersects at some point. It's not a simple closed figure. Number 16, line segment, is any portion of a line that has 2 endpoints. Isosceles triangle is a triangle where 2 of the sides have equal measures. A transversal, I don't remember talking about that. It might have been in a section we decided to skip over. But a transversal is where you have 2 parallel lines. I messed it up a little in my drawing, but those lines are supposed to be parallel to one another, and you have a line that intersects them. This line here is called the transversal. I will not test you on that. A vertex is the point from which two rays extend. Okay, we could talk about a vertex of an angle. We could talk about the vertex of any polygon. This has 5 vertexes, 1, 2, 3 right here, these points, 4 and 5. And a circle is a simple, closed figure where all the points are equidistant from the center. So if I drew a line there, line there, line there, line there, line segment, right? All the way around anywhere, all those line segments would have the same length. Okay, number 21. Roman numerals, good review, 1729. Okay, so how would I write? So this is 1,000, right? 729. Let's do it in each. 1,000, 700. How do we write 100? 100's that, and 500 is D. So we have to write the D first. 500 plus 2 more 100. That's 700. 20. How do we write a 10? So 20 would be 2 of those. 10, 20. 9. How do we write a 1? How do we write a 5? Okay, but 4 and 9 are special. 4 and 9 are always special. Why? I want to think 10, 9 equals 10 minus 1. So if I think, how do I write a 10? So I would write 10 minus 1, and how do I know I'm going to subtract it? If I just wrote that, that would mean 10 plus 1. So to subtract it, I need to put the 1 before the 10. So anytime the order is awry, in other words, normally I'm going from larger to smaller values in Roman numerals. Larger to smaller is normal. In other words, 100 is greater than 50, is greater than 10, is greater than 5. Okay. But anytime the order gets messed up, like that means subtract. So that represents 9. So to represent 9 over here, I go 1x. Now let's read it back. Let's read this one back. 500, well, I could do that. 559. I'm sorry, 100. I don't know why I said 5. 159. Reading this one back. 1,729. Okay. Number 22, add -6 and +4. That answer should be -2. Hopefully you're very comfortable now with signed numbers. Subtract 3/8 from 7, and you get 6 5/8. Change 5 2/5 to an improper fraction. You should get 32/5. Find 8.5% of 2,000. Your answer, number 25, is $164. What would I do? Take 2,000 and multiply it by, what's 8%? Is 0.08, and 1/2 more is 5. So multiply it by that. Okay. Write the simple interest formula. I equals PRT. I don't think we covered that, so number 26 is optional. 27 is write the prime factors of 40. 40 is the same as 2 to the 3rd power times 5. Remember what we do there? These are review. We'd split that into any 2 multipliers, split that again till we're breaking everything down to a prime. And I have 3 2's, so that's 2 to the 3rd power times 5. 28, find the percent of discount if a $50 dress is sold for $40. And the answer would be 20%. Now, I'm not sure we actually That might have been something we skipped. Okay, so you might have to skip that. Not to worry. Number 29, simplify that. We add or gather, I say, like terms, and the answer should be 8x squared minus xy. And number 30, to round it to the nearest hundredth, 6.439. You have to identify the hundredths place. Okay, so I look to the right. If this number to the right is 5 or above, which it is, you want to bump this number up. So the answer should be 6.44. So I appreciate the fact that this book does a lot of review for you so that when you finally get to a midterm or a final, that you haven't totally forgotten your old ideas. Now we're going to move on to 2 new ideas, perimeter and circumference. We are, by the way, skipping over sections 8.17 through 8.19. Now perimeter, this word means around. This word means to measure. To measure around is literally what it means. So when I have any type of polygon, that means the angles are going to be straight line segments, right? And I start at one place, and let's say this is 5, this is 7, this is 6, this is 4, and this is 8. If I start counting it up, summing all the way around, 5 plus 7 is 12, plus 6 is 18, 22, 30. The perimeter is 30. And if these were all in inches, the perimeter would be 30 inches. That's all there is. That's all you care about. Now, if we have a regular polygon, it means that all the sides are equal, regular. So this would be a regular square. And if this is 3, what do I know about a square? This would be 3, this would be 3, this would be 3. I could either start at one point, add all the way around, 3, 6, 9, 12. Or I could know, because they're all the same, I could say the perimeter equals 4 times, because I have 4 sides and they're each 3 inches, so 12 inches. Okay. So if I know that about a square, what if I had a regular hexagon? A regular hexagon, I'm not even going to draw it. A regular hexagon, and each side is 4 feet. What is the perimeter? Well, how many 4-foot segments do I have? This means 6 sides, right? So the perimeter is 6 times 4 feet, or 24 feet. See how that works? If I had talked about a triangle, a regular triangle is with each side. Regular means all the sides are equal. Each side is 2.5 inches. What would my perimeter be? Well, if I'm picturing it and adding it up, it'd be 2.5 plus 2.5. That would be 5 plus 2.5 more. That would be 7.5 inches. Or I would take the perimeter is 3 times 2.5, right? Because I have 3 sides. Now let's talk a moment about a rectangle. If I have a rectangle, I know that this side is the same as this side in measurement, and this side is the same as this side in measurement. So if this is called the length, and this is called the width. So if you have a rectangle, that has a length of 5 inches and a width of 2 inches. What would be the perimeter? Well, if I were to draw it, my length would be 5, my width would be 2, my length would be 5, my width would be 2. If I started and added all around, I'd get 2 plus 5, that would be 7, plus 2 more, that would be 9, plus 5 more, that would be 14. There's 3 ways to look at this, okay? I could just add them around just like that, or I could say, okay, my perimeter for a length, for a rectangle would be 2 times the width plus 2 times the length. I always write my L's that way rather than, or I could write it as a capital. I don't like to write just L because that's hard to tell what that is. Okay, but I could do it that way. Sometimes that can be confused too. It can be look at an angle or something, but we'll do it that way. So how would I do that? Well, the width was what? 2. So that'd be 2 times 2 plus the length was 5. 2 times 5. That would be 4 plus 10 or 14. Same thing as I got above. Okay, here I guess I never wrote it down. But the perimeter is 14 inches if I just march all the way around and add it up. If I use this idea, because I know both the widths are the same, I get the same answer, right? And if I did it this way, okay, I'm going to add up half of it. I'm going to add up, let me get another color to illustrate this. I could add up this, and then add up this, and that measurement is half of the whole, because this and this side would also be the same. So I could say 2 times the width plus the length. See how that works? And so then I would say 2 times the width is 2, and the length is 5, and that equals 2 times 7, and that equals 14. 3 different ways to approach it. Okay. If the measurements aren't even like that, if it's not a regular figure, you just, like we did over here, you just add them all up. And I think I've covered it all. Okay, as far as that page goes. So the perimeter is going to be, you're going to have homework here. Actually, you know what? I better go to another tape. So this is part 1. I'll finish on part 2 and talk about circumference because I'm getting awfully long to be able to download this. Okay, we'll meet you back for part 2.